Hello. In this video, we're going to examine how we analyze data that comes in pairs. So this scenario might arise when we measure something before and after an intervention, or maybe something on the right side or the left side. But the essence of it is that every measurement in one group is linked with one measurement in the other group. So we have one patient or one subject generates two numbers. So in this example, we're going to look at the situation where we have before and after measurements. So here I have a data set of, it's about 120 subjects who had their heart rate measured before and after an intervention. What I want to do is see if there's some difference between them. Okay, so the way we do this is a paired test. And Excel will do all the calculations for you. So the first thing we need to do is install our data analysis macro. So we go to, this is a program that ships with Excel, but you have to install it yourself. So we click on File, look at the options. Then we have the Add-ins tab. It says Manage Excel Add-ins, so we click Go. And there's the Analysis Toolpack. That's the macro we're going to use for doing our analysis. Click OK. And then when I go to the Data tab in Excel, I should see the Data Analysis macro. It's up there. So we use that to do our measurements. So we're going to start off by doing a simple paired t-test between the before and after measurements. So to do this, we start our Data Analysis macro. Okay, and I'm going to scroll down here and we should find the paired two-sample t-test. Okay, so this is a t-test. It's paired because every subject we put through the experiment generates a pair of numbers before and after. Okay, so the variable 1 range, that's going to be the before measurement. I just click the column label at the top. My variable 2 range is the after measurement. Okay, now the hypothesized mean difference. Okay, my null hypothesis is that there's no difference between before and after. So the mean difference, according to the null hypothesis, is 0. Okay, I have labels at the top of each column, so I tick the label tick box. My alpha level, that's the significance level that I'm looking for, is 0.05. It's nearly always 0.05. If you use anything else, you have to justify it. Okay, and my output range, okay, this is where I'm going to put the results of the calculation. I'm going to put those up here, cell E1. Okay, so I put in all the information. The data set is there. All I need to do is click OK, and just wait a moment, and it'll do all the calculations. And here it comes. Okay, so there's our paired t-test. Okay, this is the paired t-test. Okay, I'm going to highlight the things that are of interest, the mean of the two groups before and after. I click Home and I get my little paint box here, so I highlight that. Okay, and the two-tailed t-test is here. Okay, we always use the two-tailed t-test. It's extremely rare to use a one-tailed test. So generally speaking, if you're given an option, one-tailed or two-tailed, always go for the two-tailed test. So what this does is it looked at my two columns and it's worked out the mean value of the before measurements is 67 and for the after measurements is 87. Degrees of freedom is 119 because we had 120 subjects altogether. We lose 1 degree of freedom. And my p-value is incredibly small. It's 2.5 e to the minus 19. That means it's 10 to the power of minus 19. So this is a tiny p-value. So this is extremely strong evidence against the null hypothesis. Now the p-value doesn't tell you how big a difference is or how small the difference is. It tells you how strong is the evidence against the null hypothesis. The higher the p-value, that means the weaker the evidence against the null hypothesis. And the lower the p-value, the closer to 0, the lower the p-value, the stronger the evidence against the null hypothesis. It doesn't tell you how big the difference is, it tells you how strong is the evidence against the null hypothesis. By convention, we say if the p-value is greater than 0.05, that is not strong enough evidence against the null hypothesis. It's supporting of the null hypothesis. If a p-value is less than 0.5, that is evidence against it. And the more less than 0.05 it is, the smaller the p-value, the stronger the evidence against the null hypothesis. So that's how we interpret a p-value. Okay, so here we have extremely strong evidence against the null hypothesis. We have a tiny p-value. Okay, our t-statistic is -10. The critical value is 1. So it's extremely strong evidence against the null hypothesis. But I'm really more interested in knowing how big is the difference, not just whether there is a difference, it's not just whether it exists, but how big is it? And for that, I need to calculate a confidence interval. Well, I can do that with Excel as well. It's not difficult at all. What I need to do is generate a third column. Here I have before and after, and I also want the difference. Okay, the difference, well, that's simply, it is the after measurement minus the before measurement. It doesn't actually matter which we subtract from the other, as long as we do it consistently all the way through. So I just drag this formula all the way down. So as long as we do it consistently through the whole data set, it doesn't matter whether it's before minus after or after minus before, as long as it's consistent. So now I have 3 columns, okay, and I ask Excel to do the analysis here. And for this, I use the t-test macro for doing a t-test. But what I really want is a confidence interval. Now I get those in the descriptive statistics. So if I click on data analysis here, I bring up my macro again, and I'm looking for descriptive statistics. It's got to be here somewhere. There it is, descriptive stats. I click OK. Okay, now my input range. This time I can put in all 3 columns together. All 3, okay. It's grouped by columns, okay. I do have labels in my first row, that's correct. And my output, well, where am I going to put my output? I'm going to put it up, let's just put it up here, let's say. So I click there and I'm going to put the answer there. I want to print out summary statistics for the whole thing and also confidence level. This is the thing we're looking for, isn't it? Confidence level, and it's going to be a 95% confidence interval. Okay, a confidence interval is a range of numbers from one to another, and my confidence level, that tells me how confident I am that the true universal mean is somewhere in between in that interval. Okay, so the confidence level tells me how confident I can be that it is there, and the interval itself gives me a range. Okay, all my information is in there and I have my data set, so I click OK. And here we are. Now it's a bit squashed up, so I'm going to reformat it slightly. I go to Home, Format, Auto Fit the column width, so they all spread out nicely and I can see them properly. Okay, and also I have a couple of redundant labels that I don't really need, so I'm going to just delete these ones. So I right click here, delete, shift the cells left, OK. And again, there's the same here. I don't really want this. These are just extra labels that I don't really need. So I delete that as well. Shift the cells left. OK, and I'm going to just being pernickety really at this point. Okay, so I have the before, after, and the difference. Okay, well, the mean for the before group is 67. Well, I worked that beforehand when I did the t-test, so that's okay. The mean after is 87. Well, that's what I found there. The difference, now the mean difference between the before and after measurement was 19. And this got a standard error that's a little bit bigger than those. Standard deviation is, again, a little bit bigger, which is what you'd expect. And at the bottom here, I have confidence level. Now, that's what I've been looking for, isn't it? Except confidence level isn't actually, I'll just highlight this now. Confidence level gets me toward it, but it doesn't actually give me the confidence interval. The confidence level tells me the width of half of the confidence interval. So the actual confidence interval, well, it's got an upper bound and a lower bound. Okay, so the upper boundary is it is the mean plus the confidence level. Okay, the lower bound equals the mean minus the confidence level. You've heard of the formula mean plus or minus 2 standard errors. That's basically the formula we use, except it's not exactly 2 standard errors. It's the amount that gives me a 95% confidence interval. It's actually 1.96. But it depends on the sample size and it depends on a number of other things. But Excel works out all the sums for you. So we have our confidence level there. We just take the mean plus or minus this, and that's my upper bound and lower bound of the confidence interval. I'm going to just drag this formula across, so I'll work out exactly the same calculations for the other 2 columns, and there we are. That is what I've been looking for, my confidence interval for these 3 measurements, the before, after, and the difference. Okay, so my confidence interval for the true population mean is, well, my observed mean was 67. My confidence interval says I can be 95% certain that the true population mean is somewhere between 64 to 70. My observed mean after was 87, and this confidence interval tells me I can be 95% certain that the true population measurement after the intervention is somewhere between 84 and 89. Okay, the thing I've been looking for is this one here. My observed difference between before and after was 19, and my confidence interval tells me this, that I can say with 95% certainty that the true population difference between before and after is somewhere between 16 and 23 units. So I can be very certain it's not 0, there is a genuine difference, and I can say how big that difference is. It's somewhere between 16 and 23. With a bigger sample size, I would have a narrower confidence interval. With a smaller sample size, the confidence interval will be wider. So this is how we use Excel to work out our confidence interval of an experiment where we measure before and after. So where we would use a t-test for a paired sample. Thank you.